Welcome everybody. This is the 3D Printer Chat podcast, the podcast for 3D printing enthusiasts and manufacturers and everybody into 3D fabrication. And a little bit of a change this time. We're going to talk about laser engraving with George Fomitchev. And George Fomitchev is from endurancelasers.com, and he has enabled a lot of people to turn their 3D printers into laser engravers. So if anybody's familiar with 3D printing and the 3D printing history, you'll know that 3D printing grew out of CNC. Laser is another type of CNC. It's subtractive instead of additive, but a lot of the same parts are used. And this is fascinating for me because I'm into laser cutting and laser engraving. Usually it's very difficult, but George, you've made it easier for people, right?
Yeah, thanks, Chris, for inviting me. I'm happy to give a talk and explain people about what we're doing and how we help enthusiasts and hobbyists to upgrade and improve their printers and CNC machines.
Yeah, so let's start with the laser itself. We're not talking about them big, huge CO2 lasers, aren't we? We're talking about something that's quite simple and small and relatively, in comparison, inexpensive to get started with, right?
Yeah, that's correct. So we're talking about diode lasers. In other words, they're called solid-state lasers. So what the difference between them and CO2? So CO2 are much bigger, and they use CO2 gas to produce this power output. So in our case, we use a diode to generate light in a range of 445 nanometers. It's like purple, blue, and that's actually a very small piece of metal inside and a crystal that generates pretty big output. So the maximum power we made is 8-watt laser. So we actually use 6-watt diode, and we do it a little bit overclock, if we can say that, and a bit overpower, but we do it very accurately to make sure that it will last for a very long and an extended period of time.
And you don't need all the liquid cooling and all of those things that you'd normally see on a larger laser cutter. You can just strap this thing to a 3D printer.
Yeah, that's correct. We use airflow, so just air blowing is enough because we use pretty good heat sink, and to make sure that all heat is dispersed out, and this airflow is actually pretty good. So for on 8-watt laser we install 3 fans. So 3 fans actually cool this system. So the good thing about airflow that it doesn't have a great weight, so it's pretty light, and you can install on almost any 3D printer and CNC router. So, and you don't need this bulky water cooling system. So that's quite simple. So it doesn't take more than like 10-20 minutes if you're advanced, or like 30 minutes if you're intermediate level enthusiasts to install a laser on your 3D machine.
So I'm already excited about this because I know with my little 5-watt laser I've been able to engrave wood and even like cut acrylic and stuff, and you've got an 8-watt.
Yeah, that's pretty powerful. May I ask you, so did you buy your 5-watt laser on AliExpress?
I got it from GearBest.
Ah, okay. So
and it's at this point it's basically a toy. So I'm excited about to hear that you've got things that actually work as useful tools. So I've got a Chinese 40-watt K40 laser, and I've got a little aluminium extrusion, 2021, and I've got a little 5-volt desktop toy one with a tiny laser in. So this, being able to use a 3D printer, sounds just the thing for me. Now, that just reminded me. So the little desktop thing is USB powered. It takes 5 volts, just like a a camera charger or a phone charger. Does this 8-watt laser and these 5.6-watt lasers, do they run off of the machine's power, or are they externally powered?
Yeah, they have external power. For example, in a 3D printer, it's enough power from a heater, so you can connect it to a heater and use like 10 amps and 12 volts out from your power adapter. Or on CNC machines, they usually don't have power because they have like kilowatts of power on the spindle. So in our case, laser consumes about 3, 4, 5 amps, and 12 volts. So generally it takes about like 40, 60 watts of power, and it generates like 5 or 8 watt, light power. So that'll enable you to cut. So the best result we got, that we could cut 4 millimeter of plywood just within one path. So as far as I know, not many Chinese CO2 lasers can cut 4 millimeters of plywood with just one path. One trick.
Yeah, certainly not cleanly, and one pass. You would have to do multiple passes.
Yeah, you may watch our video and see how we did that. So we actually explored one very tricky thing that mostly non-Chinese manufacturers, they actually know about it, that you can use short focal lengths, and then you'll be able to cut really, really good with a good result. So as you probably know from physics, that power of laser loses its power just in equation, like in a square of the range. So less range from the laser goes to plywood or wood, so more power it brings in a dot. So we use actually short focal length G2 to do wood cutting, plywood cutting, and we actually cut 8 millimeters of acrylic even, but it required like 3 passes. But 8 millimeter of dark acrylic is really a really nice result. We are happy with that.
Yeah, I mean, being able to do acrylic, you can do enclosures, and for using plywood, you can do like crafts and signs and stuff. So that is mostly what people use the larger lasers for, and being able to add it to a 3D printer, that means like you could use a CR10S5 or a G-Max and have 500 millimeters by 500 millimeter bed.
Yeah, right.
So you have the laser, you've got the external power, or you can draw it from the heat system. So the next thing would be you have to mount it. So do you have custom mounts to put it on the X carriage?
Yeah, also a good question. So once we started, we made an open version of our mount system and uploaded it on Thingiverse. So anyone actually could download our mount, do any changes, add holes, do some, and print the mount out. So that was our part of our marketing strategy, because it was pretty hard to find out and to make sure that it will be compatible with most 3D printers. So right now we actually decided to move. So there is a good thing when you do a 3D printed mount, that anyone can change it, and it's plastic, so it doesn't have a big weight. But the bad thing that when you do shipping, this plastic done on 3D printers, it's not so how do you say, it could be broken while we send it, while transportation. So, and now we decided to move it to aluminum. So we have aluminum shape, and we try to get all responses and get all feedbacks about the mount. So our mount is quite universal right now, so it won't be a big deal to install it near the extruder, or if you remove extruder, just replace an extruder and insert it, just add our laser.
So you can have it in addition to an extruder. You don't have to replace the extruder.
Yeah, that's what we did on one house. So you can do 3D printing, and then you just click a button. Actually, we install it on a 3D printer, and you can do laser engraving. and that's pretty much the same G code, pretty much the same everything. Well, actually, G code is different because you have to set up your laser on a certain height. And what I actually like about 3D printing, that actually installing on a 3D printer, that you can change that axis. So when you do laser cutting, you need to be always in focus. And once you cut, once you made, first layer, you need to go down. So then you go down one step, or like 2 steps, 3 steps, and you always be in focus. That's why even with 5.6 watt laser, we had an experiment where we have cut it. We have cut 8 millimeters of plywood. Of course, it required multi-passes like 40 or 50, but still, 5.6 watt cuts 8 millimeters of plywood. It's pretty amazing.
Yeah, that is really cool. So you said the G code is the same. So how do you switch between the 3D printing and the laser engraving? I've seen ones before where the laser engraver is controlled via, I think, the fan G code.
Yeah, well, G code is almost the same. So when you do 3D printing, you have different layers. So when you do laser engraving, you just have one layer, and you just make it, running the G code in the same let's say area, in the same place. So you don't need to change Z axis unless you do laser cut.
Okay, so it's still sending extruder signals, but instead of interpreting it as extrusion, it's firing the laser on and off.
Yeah, so we don't run it at the same time. So we never
Yeah.
tried. Maybe once we will do this experiment, but don't know when.
Yeah. So is there like a switch where you switch between the laser and the extruder?
Yeah, we just made a button upside on top of 3D printer. When you just click, you just switch from on to off the laser. It means that the power can go to laser. But like I said, in a G code, you run pretty much the same parameters that you use for 3D printing or laser engraving. You just need to switch a button on top of a 3D printer. That's it.
Right. So I'm guessing you have to wear the special laser glasses because it would be easy for somebody to mistakenly fire this thing.
Yeah, absolutely. We always say that you need to wear protective goggles. We provide red and green goggles. Just make sure that you'll be safe. Never look at the laser, and even the light, reflective light, could be dangerous. So you have to be very, very cautious when you work with a laser. And always, get ready. Keep your place out of fire, because it's very important to be sure that you don't have anything, liquid like gasoline.
Acetone.
Yeah, because otherwise you can have big problems, especially when you do a live cast or something.
Yeah.
So.
Yeah. I can imagine there's a few 3D printer environments that have got some very flammable liquids that people would have to hide away.
Right.
So it sounds to me like it's a very quick and easy switch, which means that I think that this is just purely not enough people know about this, because I'm in a lot of 3D printing groups, and it's only really the little almost laser pointer lasers that people have really talked about. And then I'm in a lot of laser and CNC groups, and everybody's talking about either getting the cheap dedicated kits, the Chinese kits, or the K40, which is $500 upwards. And then we're talking about the really nice ones like Trotec and the Glowforge. This sounds like something that you could take your existing 3D printer and very quickly be laser engraving. So is there all instructions and videos for how to get started, and what is the purchase like? Do you just decide what strength do you want, or how does somebody go from being interested, listening to this podcast, and actually getting one of these on their machine.
Yeah, I don't want to make an unsolicited advertising here on podcast, but yeah, you're welcome to visit our website endurancelasers.com and explore and learn more about what we're doing. So the thing is that we do really provide full guidance and tutorials how to connect, how to install, how to convert vector raster image into vector, how to convert into G code. So we try to get these technology, more popular. And you're absolutely right that it's a big, it's quite difficult to struggle against Chinese low price kits for their lasers and engraving machines. But a lot of people come to us and say, hey, we've already bought Chinese and worked nice, but it burned out in like 10 hours. I want your laser because they are not going to reply me, they are not going to support. So, and we provide full time, and when I wake up, I check my messengers, because anyone can write me in Facebook, in Skype, in WhatsApp, Viber, Telegram, even Google Hello, even Hangouts. So I'm always in touch and ready to assist and help our customers and who's not sure what laser he would like. So a lot of people come to us and say, hey, we want something to engrave, and then I try to help to qualify what they're exactly going to cut and engrave, because for some cases they need 3.5 watt laser, sometimes they need 8-watt laser, and I try to find out if our product will fulfill and will match their expectations. We also are working on more powerful lasers, and we're also working on more advanced technologies when you can engrave on metal. So right now you can engrave on anodized or painted aluminum or painted steel, and if you want to engrave on just steel surface that is not painted, then you need to do electrolysis process. So we also show it on our video on YouTube, where we show full guidance how you can use different technologies and combine it with a laser. So for example, you have a aluminum, you paint it out, you engrave, you remove the paint, and then you can do chemical process, like put it into ferrum chloride, and then do some chemical processing of with your aluminum piece. So that's actually part of our strategy to help to explain and explore these opportunities together with community.
Yeah, and one of the things that I think stands out as well is because you're using the G code and you're talking about vectors, that also makes it more useful, because a lot of the Chinese lasers are only set up to do bitmap laser engraving.
Yeah, right. So, K40, they do bitmap, but they do it pretty fast. So their technology, their stepper motors are a bit different, because you can also do bitmap on, just convert bitmap into G code. It'll just take a lot of time to print out, and the file will be very, very big. But for example, to engrave R2D2 or BB8 with a size of, like, say, 30 centimeters on 30 centimeters, and when you want to have a photographic quality engraving on a plywood, then it takes about a day to engrave. So it takes some time, because it goes one pixel after another, so it takes pretty much time to engrave. And the good thing that our lasers, they support TTL, so you can actually adjust power on every single pixel. So the thing is that our lasers are also compatible when you run bitmap engraving, but in G code, you cannot change power every line. Oh, yeah, of course you can, but there are no good converters, as far as I know, that would help you to change power in different areas. So you just need to...
You can change the speed, right?
Yeah,
so
the
speed and the...
Yeah, and the good thing, that is a trick. For example, if you want to do laser cutting, for example, of very small thing, for example, like 1 centimeter on like ½ inch, for example, and you need to have pretty high speed, because otherwise this power will just burn out. So there are some nuances when you do laser cutting as well. So you have to find parameters like speed, intensity, and delay on a dot, that to make it, very accurate, because many people, they want, very accurate and nice pictures. They don't want when it's, burned around. So these parameters, it's always a trick to find out. And we have a catalog where we show the best parameters for plywood, for wood, for acrylic, for felt, let's cardboard, hardboard. So we try to share these parameters with our customers.
Yeah, that's excellent. So, in terms of getting this out into the market and being like this cool thing that people don't really know about, you're making these things in America, in the United States. Are you going to be going to the maker fairs? Are you going to be going to the 3D events? Where are people going to be able to see this in action?
Yeah, so I've been in Maker Faire twice, actually. No, 3 times. I've been in Moscow Mini Maker Faire. I've been in New York last year. I showed up and presented lasers and 5.6 watt laser over there. And we've been here in Moscow this year. So yeah, we show to makers, we make demos, but it's pretty hard to run experiments on Maker Faire. And we also partners with Geek Picnic. I'm not sure. So, are you familiar with them? Geek Picnic.
Yeah, I've heard the name. Yeah.
Yeah, so we also bring our stuff there, and we do laser engraving and laser cutting for visitors. Sometimes we do it for free when we do it on our when we show experiments. But sometimes people say, "Hey, please do it on my iPhone." And then we say, well, we're not sure about parameters. We don't want to mess up with your smartphone. So, but people are happy to give us their wallets, their business card holders. Sometimes we even engraved on one guy tie. So he said, well, just write something on my tie. And it was kind of fun. Yeah, so a lot of things, a lot of fun.
Cool. So what's next for you? What you said you're going to try some higher powered lasers. Are you going to go to 16 watts?
Yeah, so we are thinking about it, because we understand that people require, more advanced and more powerful technologies for, like, they want to cut, let's say, copper, aluminum, and even steel. So you cannot really do it with diode laser. You can hardly do it with CO2 laser. So we're actually looking for partners and suppliers for fiber lasers. So we're actually thinking about this direction. I'm not sure that we'll move there, because it costs a lot. So, for example, good fiber laser is about thousands, dozens of thousands of dollars, and they have pretty big weight. So it might not be a good thing for makers, because we want to be in maker community. We like it. So for 3D printers. So
fiber is cutting metal.
Yeah,
and
absolutely.
Yeah.
So we're actually thinking maybe we can improve. Maybe we can add several diodes into one tube and make sure that the heat dispersed accurately, so that the diode and the crystal would not die too fast. So we might do some experiments. It'll take probably some time, and probably we'll start thinking about it after New Year, because now we are ready for sell-offs in Christmas sell-offs and New Year sell-offs. So we're getting ready. We are replacing our stores. So we want to run discounts and off for this Christmas to bring people happiness and joy with a laser engraving next year.
Well, I'll be happy and joyful if you send one to me to review.
Yeah, we actually planned. We spoke, and we have an entire pipeline. We just was off in our last shipping period, so we just had only one left, and it's in the office. So yeah, we definitely will send it probably by the end or beginning of next year. That's 100%. We'll send you one for review.
Perfect. I'll do lots of videos.
Yeah, that's fun. That's great.
So thank you very much for coming on the show, and we'll have to have you back and talk about projects and any news you have with the new year, because I think this is going to be something a lot of people will be interested in.
Yeah, thank you, Chris. And if you make discussions and you maybe invite more people, make some sort of topics, when you connect all people together, we can talk about, argue and make it more fun. So yeah, I'll be happy to
Yes.
talk, to give another talk and answer your questions. And well, thank you.
Awesome. Thank you everybody else for listening. Please do subscribe, like, comment, share with your friends, and check us out next time.
Thank you.